This is the largest of 5 plants that Metro Vancouver operates.
By converting the biogas into energy, we can reduce the electricity consumption of the plant.
We look at things down to parts per trillion levels of certain compounds in the water that shouldn't be there.
Hi, I'm Vanessa Timmer. Welcome to the Sustainable Region. Today, I'm at the Annacis Wastewater Center. Metro Vancouver opened this $9 million building in fall 2011 to provide the international science community with a place for innovation. These days, wastewater is seen as a resource full of nutrients and materials that can be drawn out and used. Here, scientists are able to use that wastewater resource to develop ideas, business opportunities, and create a hub of learning. If you ever wondered what happens when you flush, this is the show for you. Today our stories will plumb the depths of wastewater. Wastewater comes from showers, sinks, and toilets, and includes human waste, food scraps, oils, soaps, chemicals, and objects that do not biodegrade, along with fine sand and grit. We don't want to put that stuff back into our environment, so wastewater generated in Metro Vancouver is treated at one of 5 treatment plants before being returned to our local waterways. There's one on Burrard Inlet, another on the Strait of Georgia, and 3 along the Fraser River. The Annacis Island facility handles the wastewater for over 800,000 homes in Metro Vancouver. It provides what's known as secondary treatment, where 95% of the suspended solids are removed and the oxygen demand of bacteria is greatly reduced. Reducing oxygen demand is essential to make sure that fish and aquatic insects aren't competing for oxygen with high levels of bacteria in the water. It's a fascinating process. Let's take a tour with plant operator Craig Meyer to find out how it's done. The Annacis Wastewater Treatment Plant has been in operation since the 1970s and discharges its treated water into the Fraser River. In 1998, it was upgraded to a secondary treatment plant. Over 5,000 pieces of equipment are controlled by a complex, highly automated system.
Hi, my name's Craig, and we're here at the Annacis Island Wastewater Treatment Plant. This is the largest of 5 plants that Metro Vancouver operates, and one of the largest plants in all of Western Canada. Today, we're going to go for a tour around here, and I'm going to explain a little bit about what happens here at the plant. The first stage of treatment takes place in the influent pumping station, where solid debris is removed from the wastewater. So we're here in the Annacis bar screen room, and what we're doing now is we're going to start removing all those sticks and rags and other things that people put down in the toilet, like tampon applicators and condoms and anything else you really can think of that these screens will remove. What's happening here is this rake's going to go down and it's going to pull in through the screen all this debris, and it's going to pull it up. As you can see, it's going to go and get scraped off into an auger. Later on, we're going to take all that debris and we're going to squeeze all the water out of it, and then it's going to be sent off to landfill. All that water is pumped up after it's been screened, and it's going to go into this PA tank behind us here. What happens is we inject air into the water and we slow the velocity of the water down, and that allows all the heavier inorganics like the grit and sand to settle out with the lower specific gravity of water. The debris, grit and sand is collected, removed, and sent to the landfill. The wastewater is then pumped to the sedimentation tanks for primary treatment. Now that we've completed preliminary treatment, which is screening and grit removal, it's time for primary treatment, which really means physical treatment, or treatment by settling and gravity. What's happening here is, as the water flows through this tank, it's moving very, very slowly. All the scum, fats, oils, and greases are floating to the top of the surface, and all the heavy organic matter is settling down, primary sludge. So we're going to collect all these fats, oils, and greases at the front of this tank, and we're going to then dewater it and then send it to landfill. But all this organic matter, the primary sludge that we collect at the bottom of the tank, that's going to further go to thickening and then digestion. Now that we've finished primary treatment, it's time for secondary treatment, which is biological treatment, utilizing microorganisms to treat the wastewater. As you can see behind me, we have 4 large domes. Those are the trickling filters. Inside the trickling filters, we have about 15 feet of this plastic media. Basically what's happening is as the water filters through this media, this biofilm or this slime starts to grow on this media that has all these organisms, and they're going to start consuming all this soluble organic matter and this really finely suspended organic matter that we couldn't settle out in the primary sedimentation tanks. Later on, all that biomass will slough off of this media, and it's going to go into the underdrain system, and it'll go on further downstream into the process. As the wastewater leaves the trickling filters, you can see those pyramid-shaped domes behind me. Underneath there is the solid contact tanks. As the wastewater goes into those tanks, any remaining soluble BOD will be converted into suspended solids, which we can then settle out into secondary clarifiers further downstream. After the wastewater leaves the trickling filters and solid contact tanks, it comes here to the secondary clarifiers. Here we have 12 secondary clarifiers, about 7.5 million liters each. What happens is the wastewater slows down and it's going to reside in this tank for about 4.5 hours. And in that 4.5 hours, it's going to slowly settle out all that heavy material. And the water on the top is very clean. As all that mass on the bottom, we're going to collect that secondary sludge, and that's later going to be thickened and then digested. Here at the Annacis Island Wastewater Treatment Plant, we have 4 12.5 million liter anaerobic thermophilic digesters. What's happening here is we're taking all the primary sludge from the primary treatment portion and then all the secondary sludge from the secondary treatment. We're mixing that in those tanks at 55 degrees Celsius for around 20 days. That sludge is broken down in a 4-stage process. All that sludge, after it's been cooked for 20 days, is going to be sent to dewatering.
At this point, we are only partway through the process. Later in the show, we will look at how the water is tested to ensure it's safe to release back into the environment, and look at ways in which Metro Vancouver extracts as much value as possible from this resource. When we return, a look at one of the first research projects to get underway at the Annacis Wastewater Center.
We all have too much stuff, but getting rid of it in a sustainable way is tough. Like all that old sports gear or that leftover paint that can't go to the landfill. Metro Vancouver's new We Recycle app turns your iPhone into a reuse and recycling powerhouse. It'll find the nearest place for your stuff to go. Simple, sustainable. Everything has its place. We Recycle, now available in the App Store.
Welcome back to the Sustainable Region. I'm Vanessa Timmer. I'm at the Annacis Wastewater Center, and in here is the research hall where a variety of experiments and test projects take place. These pipes are directly connected to the wastewater treatment plant, so there's a fresh supply of effluent for use in experiments. Maybe an icky thought for you and me, but it's great news for researchers, such as the team that recently brought in some machinery to help extract phosphorus.
Phosphorus is used in fertilizers and is an essential element for healthy and productive soil. But our world's phosphorus supplies are dwindling. Recovering phosphorus from our wastewater not only makes use of a valuable resource, but protects our environment as well. An equipment delivery in late January 2011 was the start of a University of British Columbia project at the Annacis Wastewater Center, exploring ways to extract phosphorus from liquid waste.
It's very exciting because we've been dreaming about this technical scale pilot, as we call it.
The shipment brought the first pieces of a struvite reactor, which will be used in a University of British Columbia research project.
What you're seeing today is the assembly of what we call a struvite column. The purpose of the technology is to remove phosphate from the wastewater, and we turn that phosphate into a reusable product, a fertilizer.
This project will be the first to operate in the newly built research facility, which is linked to one of Metro Vancouver's wastewater treatment plants.
To have a facility where we have instant access to primary effluent for final effluent, centrate, which is what we use as the feed source for our reactor, is fantastic. We just plug into the wall and open a valve, and there we have it.
The reactor's ability to draw phosphorus out of the wastewater may also improve operations at wastewater plants.
At treatment plants, and the Annacis plant, which is where we're located, is an example where they can at times have the formation of an unwanted deposit.
The deposit is the phosphorus-based mineral known as struvite, and it can clog up pipes.
What we do with this technology, in essence, is we force the formation of this material in our reactor, and therefore we remove that from the liquid portion to eliminate the problem in the treatment plant.
This phosphorus research will build on previous studies the university team has done at other locations.
This is a larger unit, so it means we can study more things, and it's been like a dream come true watching this center go together, and then to have the honor of being the first technology to be studied in the center.
Check this out, a cantaloupe. And now, a plastic bag.
Kids, stop annoying the yard bin. Put all your food scraps and food soiled paper into your yard waste bin, but no plastic bags, please. Welcome back to the Sustainable Region. Never pour grease of any type down the drain. It can clog pipes and cause sewer overflows. While households do contribute, the vast majority of grease in our pipes comes from restaurants and other commercial kitchens.
Workers are using heavy equipment as they move slowly from manhole to manhole. The sewer lines that handle our flushes also get a regular flushing themselves. A hose is fed into a sewer access point where high-pressure water is used to clean the pipe's walls. A camera goes into the sewer from the upstream end to follow what's called the flushing hose on its return journey. Maintenance workers use video imaging from the camera to look for trouble spots. The white parts that you see in the sewer pipe are hardened grease, mostly from commercial kitchens.
If you leave it alone, then there's the potential for the grease to build up to become a grease blockage. And then when you have a heavy rainstorm, you could have the sewer back up and overflow.
The Marsh End pumping station is one of more than 500 facilities operated by Metro Vancouver that pump sewage uphill until gravity sends it to the closest treatment plant. Here too, grease is what they're targeting in the station's wet well.
If it does sit for a while, it actually gets to the solidity almost of concrete. And without regular washing of the wet well, that'll just keep on going and building up. And chunks will start breaking off, which can lodge in the pumps and just cause all sorts of havoc.
Commercial kitchens are part of the problem, but they can also be part of the solution with responsible management of the grease they inevitably produce. At this restaurant, the grease trap is pumped out by a trained professional at least once every 3 weeks, and much more often in the busy summer months.
If you consider how many restaurants are out here, how much grease is utilized in the course of a day, if it's just going directly into our sewer systems or into our drainage of any sort, then we're going to see ultimate problems at the other end.
The grease that's collected can only go to one of Metro Vancouver's 5 wastewater treatment plants. At Iona, a special grease collection facility separates out the solids for incineration and uses the remaining grease to help make methane gas, which the plant uses for power. In this case, grease is actually useful, but elsewhere in the plant it can really gum up the works. Ultimately, it's the taxpayers who are footing the bill for the $2 million Metro Vancouver spends annually to deal with grease in the sewer system.
Welcome back to the Sustainable Region. I'm in the lecture area of the Annacis Wastewater Center. If my voice sounds a bit echoey, it's because this is a large space. The windows here face south, so natural light can come in when the sun is low in the winter. But in summer, the overhanging awnings block the sun. It's part of the building's LEED sustainability designation, along with features like reclaimed wood beams and toilets that use water collected off the roof. Some new ideas are being tested at the treatment plant we've been learning about, such as the co-digester. It turns liquid waste into a money-making resource.
The co in co-digestion refers to mixing organic wastes with the wastewater and using bacteria to digest them together. It's a cutting-edge approach to extracting value from materials traditionally thought of as waste.
This is a leading-edge technology in Canada. We are not aware of any other municipalities doing the co-digestion with wastewater sludge.
The co-digester takes liquid waste such as restaurant grease, aircraft de-icing fluid, and sour milk, and adds it to the digester tanks where anaerobic treatment of wastewater takes place. The resulting mixture creates a methane-rich biogas, which is burned to create electricity.
We provide environmental friendly disposal method to those organic wastes, and therefore we minimize the cost impact of illegal dumping into our sewer system. It generates lots of energy-rich biogas, and we can maximize our energy recovery at the plant and reduce carbon footprint.
Using the biogas to generate energy converts methane gas, which is a major greenhouse gas, into the less harmful carbon dioxide. It also saves Metro Vancouver a significant amount of money.
Now we can avoid the illegal dumping of those organic waste into our sewer system. That item itself can bring us a saving of approximately $2 million a year, because once those materials are dumped into the sewer system, it will plug our sewer system. We need to spend a lot of effort and money to clean the sewer system. So this item itself is already a $2 million saving for Metro Vancouver. By converting the biogas into energy, we can reduce the electricity consumption at the plant.
One of the great advantages of the new installation of co-digestion plant here is we're able to increase our methane production in our digesters, and we're able to produce up to 50% of our electricity for this plant.
By processing these organic wastes, Metro Vancouver is generating revenue through tipping fees and reducing the greenhouse gases that would have resulted from the material going to landfill.
55 degrees Celsius.
Darl to CDAX, we are hooked up.
The process is fully automated, and operators can control exactly where in the system the material is sent, either to a single digester or distributed over many. Test operation of the co-digester is continuing as Metro Vancouver prepares to bring the facility up to its full capacity. At that time, the system will have a capacity of roughly 50 cubic meters per day, or roughly 4 truckloads daily, potentially reducing 1,500 tons of carbon dioxide emissions and generating $490,000 worth of biogas every year.
Hi, I'm Candace, and I live here in Metro Vancouver. There's more than 2 million of us living here in the region, and together we throw out 360 million bags of garbage each year. That's around 156 bags of garbage each. This is my share. Watch your waste.
Another byproduct of wastewater treatment is biosolids, also known as Nutrifor. This material is composed of the dewatered and processed solids from the wastewater. and undergoes further processing to make it safe to use as a nutrient-rich soil supplement. It's been used in landscaping here at Annacis Wastewater Centre, beside McConaughey Way at the Vancouver International Airport, and at the Delta Recycling Society's Earthwise Garden. Let's rejoin Craig Meyer to find out how Nutrifor is created.
I'm holding in my hands here Class A biosolids. This comes from the digesters, and after the sludge has been cooked for 20 days, it then goes to the dewatering building. This ultimately gets dewatered, and now I have some biosolids that's about 70% water and 30% solids. This biosolids is really rich in nitrogen and phosphorus and other nutrients. We utilize this biosolid, and it's used on old mining site reclamation and forestry projects.
Another place biosolids were used extensively was in the building of the Annacis Wastewater Centre.
Behind me here, we're mixing the biosolid soil using sawdust and sand, and we're utilizing materials that had been brought in originally for preparing the site. So we're using the preload sand as a component in the biosolid soil mixture, and we're also using locally sourced wood products for creating that product as well. And the biosolids themselves come from the Annacis Island wastewater treatment plant.
This is the final product, biosolids growing medium containing biosolids from the Annacis wastewater treatment plant. The biosolids in a fabricated soil is very useful and very unique in that because the biosolids originate predominantly from the materials that we consume, the nutrients that are in the biosolids, the nitrogen, the phosphorus, the boron, the potassium, they're all in the right ratios, and they have the concentrations in which make them ideal for growing food again. And so as a result, this growing media that contains biosolids can be used to grow vegetables, fruit, crops that we would eat.
Recovering biosolids and using them to enrich soils in a wide variety of applications is one way in which wastewater becomes a valuable resource.
When we come back, testing wastewater before it enters the Fraser River. Welcome back to the Sustainable Region. The crucial final step of wastewater treatment is testing. Thanks to strict testing and monitoring, the water that's returned to the Fraser River is treated to a standard that protects both public health and the environment.
After the liquid waste has gone through the clarifiers, it's ready to be discharged into the Fraser River. Ensuring that the treated wastewater meets all provincial requirements is the job of the Quality Control Lab.
In the process lab, we get samples from 5 different treatment plants, Annacis Island, Lulu Island, Iona, sometimes in the weekends, and also Lionsgate and Northwest Lanny wastewater treatment plants.
Each sample is tested to make sure the wastewater treatment plants are functioning properly and operating efficiently. The team checks important factors in the treatment process, such as chemical oxygen demand and biological oxygen demand. They also determine how many suspended solids are in the sample.
So what we do is we filter the sample through 1.5 micron filter. So whatever left on the filter, we'll weigh the sample so we know how much solids in our waste stream.
Well, right now I got a chromatogram up of a standard for trihalomethane analysis. You can see the components we look for: trichloromethane.
The chemistry lab analyzes the wastewater going in and coming out of the plant to ensure the effluent is safe for people and the environment.
Here we're primarily concerned with the chemical side of things in drinking water and environmental work. Make sure the drinking water is safe for the public, chemically speaking, and that any industrial discharges that are going out in the environment are below permitted limits for pollutants and so forth.
Metro Vancouver programs and policies are designed to control what industries discharge into our sewer system. But identifying chemicals that are present allows Metro Vancouver to find the source of these pollutants and levy fines where necessary.
Once a month, we do a comprehensive analysis of both the influent and effluent, there to ensure a more in-depth analysis than process control does. We look at things down to parts per trillion levels of certain compounds in the water that shouldn't be there to make sure that they're as low as possible before we actually discharge into the Fraser River. Some of the things we look for in the water are low levels of ammonia, phosphates, nitrates, nitrites, sulfates, chlorides, and of course it's purely the chemical side of it over here. Also, we look for trace level organic compounds, trihalomethanes, haloacetic acid. These are basically disinfection byproducts, which aren't very good for the health, but we try and screen them to make sure they're there as low as possible or not at all. We do make sure that their drinking water is safe, and we also participate in environmental monitoring to make sure that the industries that are discharging their wastewater effluents are below the permitted levels that they're allowed. So basically environmental work, safety of drinking water, and those are our primary concerns here.
Well, that's our show for today. Thanks to Craig Meyer for leading us around the Annacis Wastewater Treatment Plant. You can share your comments or story ideas by emailing us at sustainableregion@metrovancouver.org. And don't forget, you can share and watch our videos online whenever you want at metrovancouver.org/videos. For the Sustainable Region, I'm Vanessa Timmer. Thanks for watching.